Controllers for drives. Yesterday class we had been seen and discussed what is meant by design, how to making the control of drives by using this design. It had been some contents. That contents are introduction, dynamic model of a DC motor, block diagram of a DC motor, transfer function of a DC motor, closed loop speed control, then controller design, torque loop, speed loop, position loop. These topics are picked from syllabus what they given to you for this semester. Okay, now let us see the introduction of this. This is taken from electrical drives of DC motor. This called equivalent circuit of DC motor. It consists armature resistance, armature inductance, those two components inbuilt of this DC motor. While the DC motor running, it has to produce one back EMF across this. Okay, in armature circuit we got three kind of inputs: RA, LA, EA. Now we have to apply the supply across this equivalent circuit. Thus that supply has to be input voltage, input current. The zonal of input voltage and current we may call armature voltage and armature current. Okay, current is a passing device by using the various electrical element or electronics equipment. Now this armature current just passing through the armature resistance, armature inductance and this DC motor up to negative symbol of input. Okay, let's using this passing through the armature current, we got the electrical equations of output voltage VA or VT equal to IA into RA plus IA by passing through the inductance element. Inductance equations or inductance formulas we got L into DIA by DT plus the DC motor had been produced back EMF of EB or EA. Okay, we got this equation from this equivalent circuit. Then apart from this equivalent circuit, we have one field circuit. That field circuit always having to parallelly or similarly connected across this DC motor. That equivalent circuit says field resistor, field inductance. Okay, this input having field input, field voltage, field current. Okay, now the field current passing through these two elements, these two equipment. Now we got Vf equal to Rfif plus L into DIF by dt. So these two elements are designed by using this electrical equipment of equations. Okay, now we have to move with armature circuit and steady state circuit. Those two circuit among the representation of DC motor running constant speed. Okay, now we may know the speed equations or angular velocity of that DC motor. Comes across that speed, we got angular velocity W equal to terminal voltage by constant and production of that DC motor fluxes minus armature resistance motor torque by motor flux rating of squares. Okay, it produced three kind of classifications: field flux, armature voltage, armature resistance RA. Those three classifications comes from the beginning of flux production of DC motor. So it always keep up or kept in DC motor. This is not ignorable, but we have to analysis or study this field flux and armature voltage VT and armature resistance RA. These all are explanations we had been seen earlier class or yesterday classes. No need to explain again and again. This is enough explanation for the topic. We just move with the another topic of transfer function, derivation of transfer function. Okay, we solved three equations from this motor and load dynamics. In this motor, produce three kind of equations. These equations are right up here. We bring down that equations which is converted to Laplace transform. So I simply says the Laplace transform is nothing. We make that equation constant equation having s, differentiation having s. Okay, so don't mind that it is big issues to convert normal equations into Laplace equations. Don't mind that. So we make these equations into Laplace transform. First, we having VA. So VA of S, RA is constant. You simply put RA. IA having variations. Variations in the sense when you put or you applied across the circuit which is 5 amps. This 5 amps circulate through that circuit simply breaking down into a small or decreased from what you had applied across that circuit. Okay, so the armature current or armature voltage simply step less or loosely their original condition, so it may vary. Okay, ra into I of s plus SLA I of s, because d by dt you had put instead of d by dt is s. LA is constant, so LA into S into I of S plus K pi is constant. K pi, this is not ohm, this is omega. Okay, they put wrongly, so you done it fast angular velocity of this replacement. Okay, K pi into omega m of S. This equation comes from this differential equation. So same like similarly we make another two equations, another two Laplace equations from this two differential equations. These two differential equation comes from the mechanical load of this equivalent circuit. Okay, got it? Next, we make these three Laplace equations into block diagram of a DC motor. I think you all of you remembered the control system of block diagram making or block diagram reduction. In that control system, we have DC series armature control of DC series motor and field control of DC motor. Those two topics making of block diagram, same concept are here. I introduced, not I introduced, this is recorded in the writing author. So these three equations adopted to make the block diagram of a DC motor. For that condition we making and we converted this equation to design a block diagram. Okay, this is design concept. So we design and we create a DC motor formation. Each and every equation having input and output. So we segregate that input and output according the rule of our simplification, block diagram simplification. Okay. In the first equations, we just clarify what is input, what is output. Okay, I thought in first equation ia of s is output, because while you have to apply it across the DC motor, input is va into ia. Okay, that time the ia through these are elements, input va is present or stay on that front portion, but ia is circulating the equivalent circuit. We got ia is output, so va is input. Okay, from this input equation or from this equation, ia is output, va is minus k pi wms constant 1 by ra by 1 plus s la by ra is input. Okay, already I said a lot of explanation for this block diagram making of DC motor. Next, similarly, we making what is the input, what is the output of this equation to make the design of this DC motor. So clearly, you making these three equations for make a design. Okay. So we had been simplified these three equations from Laplace equation, which they given across here. So come, let's go with a block diagram design. Okay. In first equation, we know 1 by RA by 1 plus S into LA by RA is a constant or system. So you should put on inside of the block because this is called system. Okay. So the systems represent a rectangular block inside of it. Okay. We may know V of S is input, then this Wm of S another input of here. Those two inputs can have to adopted the summing point of mathematical equations. Okay. So these three equations arranging the order of making block diagram. Okay, this is final equation. Next, we will move with the derivation of transfer function. We know that transfer function formula is output by input. That means Laplace transform of output by Laplace transform of output with zero initial condition, because any operation or any technical issue starts from zero. So the formula indicate to us with a zero initial condition transfer function. What do you want? Any doubt? Let I start. Shall I continue? Okay. With the zero initial condition, the transfer function equations got Laplace transform of output by Laplace transform of input. We picked that formula for usage of derive this block diagram design. So we got output is y of s, so Laplace transform of output y of s. Input is r of s, so Laplace transform of r of s equal to making this formula from here. Okay, we just simplify this formula g2 of s, g1 of s into g2 of s by 1 plus g1 of s, g2 of s, h of s. Okay. Okay, this is transfer function of a DC motor. This is transfer function of a block diagram which we had been connected or which we had been seen through the blocks. But this transfer function of a DC motor comes from the electrical circuit, electrical equivalent circuit where we seen in two slides before. Okay. Wm of s is angular velocity of that motor, DC motor. V of s is input supplied of that DC motor. Okay. From those combination, we got 1 by motor constant or flux constant K pi by 1 plus S tau m plus S square tau m into tau A. Okay, tau m is replacing of variations of maximum flux production across the DC motor. S and S square is mean by the differentiation of Laplace equation. That means S is d by dt, S square is d square by dt square. So differentiation of various fluxes across the DC motor. So the equation mean that. Okay. Now we got I of s, V of s. Wm of s equal to Ra of I of s by Ra of s. Okay. So we need I of s. So denominator of Ra, we just move to right hand side of denominator. So we finally we got I of s by V of s equal to 1 by Ra S tau m by 1 plus S tau m plus S square tau m tau A. Okay, this is final transfer function of a DC motor. Okay, till this we had been seen the earlier classes. Earlier classes in the sense yesterday class we had been seen till this line. Okay, let us see the next topic of closed loop speed control. This is second topic of this unit. Okay, we just go slow down from this topic because earlier topic is we had been seen the lot of explanation and huge explanation. So this topic is fresh topic, so we will go with slowly. Okay, closed loop speed control. This is cascade control structure. Cascade in the sense already I insist two or three times. Cascade in the sense series. Okay, one component or one procedure, technical procedure handle with another according the connection of series, according their connection of nearby one and another. Okay, it had been connected or it connecting one and another. This concept is called cascade. The word cascade says two various technical issues or two blocks or two wanted design blocks connected or connecting nearby or one and another. Okay, this method or this structure represent cascade. Cascade in the sense series. Okay, if the design blocks are connected series, that blocks going to control or making the closed loop path, that whole designs called closed loop speed control cascade control structure design. Okay, can you clear the title of this explanation? Okay, if you clear this title, I will go with next. Students, kindly understand what I'm saying. Closed loop speed control in the sense one design or one technical issues or one technical concept making the closed loop format. Otherwise, output which is given to the input for checking the corrective output. Okay, that concept says closed loop speed control. That concept called closed loop speed control. Okay, this is heading explanation. Next, cascade control structure mean that cascade is series connection, two blocks, two technical blocks connected nearby of each other or one and another. Okay, these two blocks connection says cascade. So those two blocks connected in cascade format to control any one technical issues, that issues or structure called cascade control structure. This is heading explanation. Okay, inside of that heading we got one black diagram. That black diagram going to explain and says to us input is angle, that angle picked from this motor. Okay, so input is angle. After that input, it connects one summing point. After this, position controller are there. So if position controller present here, so it has some angular velocity. If position controller present here, depending upon that position controller on angular velocities of having that output. Okay, next, this angular velocity given to one kind of summing point. Why I'm saying one kind of summing point in the sense, because summing point has different signs. Okay, plus or minus or multiplication, whatever it may, the summing point receive various inputs across their adapted conditions. Okay, now angular velocity of this position controller which is given to this summing point, then speed controllers connected across here. Speed controller produce one torque of here. Okay, this torque which is applied to the summing point. After the summing point, torque controller are here. Torque controller cascade with converter. Listen my words. Torque controller cascade of converter. Already I'm saying cascade in the sense two various blocks connected a single purpose. Connected nearby a single purpose. Okay. These two blocks connected and giving a proper output by using one process, one single process. This is called cascade. Okay, that word shows the explanation and connected of here. Okay, torque controller nearby of torque controller, one converter is connected. After the converter, DC motor is connected here. Okay, this is main series blocks. Okay, now we made to closed loop speed control. My cursor is moving on the PPT, the closed loop speed control. We have to match the word into the black diagram. Okay. The DC motor fed to tacho generator. What purpose we had been using tacho generator, or we are using tacho generator? Sorry. What purpose the tacho generator used or using for DC motor or any kind of motor? What purpose? Anyone can say?